For today's video, we will be talking about oxidative cleavage. And so, oxidative cleavage is a topic, and subtopic that we will be talking about would be ozonolysis, right? So this is one of the topics of oxidative cleavage. And so for this, this is for alkenes. And so, for example, we had a structure that would look like this, right? A basic structure. And so, to find its products, all we have to do is just cut this in half and then fill them inside with oxygens, right? So a product would be like this. We have a double bond still connected to an oxygen, and we still have the hydrogens, okay? And plus its other structure, which would be this side, right? So for this, was connected to an oxygen, still connected to that hydrogens, right? So all we did was just cut the double bond in half, and all we did is just replace oxygens with them. So the reagents for this would be O3 DMS. Okay. As a matter of fact, there's actually a lot more reagents that we can use for this reaction. But for this reaction, we're going to be using the reagents O3 O3 DMS. Okay. And so for this is our final product for this structure. Okay. Let's try another problem. So for this, we drew the double one over here. Okay. And this was undergoing a reaction of O3 DMS. Right, this is the reagent that we use for this. So for this, first thing we want to do is number it actually. We have 1, 2, 3, 4, 5, 6, and 7. 7 carbons, right? Next thing you want to do is just cut it in half and actually add the oxygens on each side, right? So this would actually look like something, okay? And then there'll be a double one right here, and then another double one here. There you go. That's how the product of this would look like of adding the two oxygens. Okay, so you can actually leave it like this, but professors would actually like it to have it into a carbon chain. And so if they don't accept this, you can always make it into like this. Draw it in a carbon chain. So something like this. So we have 1, 2, 3, 4, 5, 6, 7, 8, and I just numbered it from what we got from the structure. So from here, all we do is just add that double one on the oxygen, like that. Okay, and also we have the double one over here. Okay, add the double one here with oxygen and double one here without oxygen. So something like this. Both ways is acceptable. Yeah. Try another problem. If we have this double one's right there, and this is going into a ozonolysis reaction. So from here, all we do is cut it in half, and then add the oxygens on the side. Okay, so we would have a reaction of this plus its other part. So make sure you have enough carbon. So we have 1, 2, 3, 4, 5, and 6. So we have 1, 2, 3, 4, 5, and 6 carbons. So yeah, make sure you have the correct amount of carbon. And so this is our final answer for this problem. For this next problem, so we have the structure over here, and it's reacting with the same reagent we have been using. All we do first thing see is that we see that there's 2 double bonds here. So that means there'll be 2 breakage, right? from here we can just break one of them in half and add two oxygens here. Break the other one in half and actually put two oxygens. So for our results, I will be doing this side first. So we have a structure that goes like this. So here will be the oxygens. And now here will be the, actually, we'll redraw that. Here's the first one, first oxygen. And so when we bring the other one, the oxygen here. Oops. There's two oxygen right there. And now for the other part, which will be this right here. We draw that, and then so plus, and then also double one right here. Also, we have to draw this part in as well over here. So that will be over here, adding that oxygen. Okay. So these two are the answers for this. Some teachers would like, professors would like this structure over here to be more as a carbon chain. So if we do that, we could just flip it and just put it into a carbon chain. And so it would look like something like this. So this would be final as well. These two are the same thing. Okay, and that's the structure molecule.